Hi, I'm Ned, and I've started streaming. This is a recording from my live stream over on twitch.tv/NedMakesGames. I'm live most Mondays, Wednesdays, and Fridays at 10 a.m. US Eastern Time. I'd love to see you there. Okay, hey everybody. Hope you're all having a great day so far. My day's been a little busy, but we're here, so that's all that matters. But so today I'm gonna work some more on the beginner HLSL shaders in URP project that we were working on last stream. We got pretty far. We did most of the material properties. So it's kind of funny. I had put up a poll right before the stream asking my patrons like what they wanted out of this tutorial, and like a surprising amount like don't care about the material inspector, oops, or the physically based rendering lights. So I'm gonna basically not spend as much time on that. So that means that I'm not gonna worry about copying the base lit shader exactly, and we'll just try to implement a bunch of different aspects of it. So we can still use it for some things. Like I need to be able to figure out how to support both specular, or wait, we already did that. How to support transparency. So we'll deal with that. Yeah, so that's one thing I'm not sure how they're able to support, having different transparency in the same shader. But I'm not sure. Yeah, maybe I don't need to worry about it too much, but because I mean we could just make two separate shaders, that one that's transparent and one that's not, and then kind of support you know, have a different define here that would change the code slightly. So that might kind of be easier to do. But anyway. Okay, so we had finished on the specular and metallic workflows. Right, so I can click here and it switches to the metallic workflow, which basically just changes the way that it reads from this texture. So if you have it off, then it reads the metallicity from the red channel, and then smoothness from the alpha, where if you turn it on, it reads specular highlights from the red, green, and blue, or specular color from the red, green, and blue channel, and then oh, what's it called? Smoothness from the alpha channel. Sorry, I don't know why my brain wasn't thinking right there. So yeah, when you have this on, obviously the metallicity doesn't do anything. So it just kind of depends what you like to work with. And then I can tint the specular color. Okay, and then we also did ambient occlusion. Okay, that seems to work well too. Okay, so I was gonna say, yeah, we have an emission map, but it doesn't show anything, and I guess that's because we set the emission tint to 0. Yeah, the emission is basically just like a glow on the material. All right. Okay, so next on the list is actually the opaque and transparent surfaces. But I think, well, let's see. Maybe if I can see how they do it in their material inspector, maybe it's not that difficult to implement. Okay. Um, Trying to see where they actually, I guess they draw those drop downs at the beginning in this base class. Okay, surface option, fold out. Okay, so here we have, I see some transparent. So I guess that's this. Okay, and then there's the other clipping. Okay, so do pop up. Okay, so yeah, this class is quite in depth. Blending mode. Oh, I see. Okay, so here it's actually doing the pop-up to select the mode. But property float value, okay. So here's just setting it, but I don't know where that actually does anything. I'm trying to see anything. So here's like the workflow mode that they have. Yeah, specular versus metallic. Oh. Okay, I guess this is it. Surface. Okay. And then, but I don't see where it's used. So the source blend, destination blend are here. Yeah, that's all good. This blend isn't ever set either. Okay, so it doesn't even show up here anywhere. Okay, so let's see if I can find this in the shader GUI. No. Press the wrong key there. Okay. Over here they're setting the surface type, but I don't know where that actually does anything. Oh, hey Cowie, how are you doing today? I'm doing pretty good. Trying to figure something out. Okay, so here's like another sub shader. Maybe, oh, this is just the one with a lower shader target. I was wondering maybe there's one that's for transparency. I don't see it. See, even here the render type is still opaque, so I don't know where it sets that. Well, you're taking it slow, still working on your little game project. That sounds good. Always fun. Remind me what project you were working on? Okay, well, I'm kind of stumped about this. I'm sure, like, obviously, I mean, I know how this would work in theory, but I'm not sure where this actually... Does it change the shader? Like, is there a... Maybe that's what it does. But they use the same inspector or something? That'd be kind of... Okay, no, I don't see... I was looking for like a lit transparent. It's your first game ever. It's going to be a short, slow-paced horror game. Oh, well, that sounds good. I think that's probably a good place to start. Because there's probably a lot of resources about that kind of thing. Okay, well, I don't really want to sit here and not do anything. So I'll just make a separate, I mean, it's probably fine. We could just make a separate shader that's for transparent materials. And we can pretty much use the same setup here. We would just change some of the options. And maybe I can find out how it does that, or how Unity handles it. Okay, because it sets the surface type. Oh yes, I probably should have searched for this, but... Okay, so that's all in here. Okay, so yeah, it finds the property. That's fine. Okay. Okay, yeah, so if it's surface, then it draws a blending mode, or if the surface is set to transparent, then it draws a blending mode property. Okay, so here maybe is what happens. Is where the magic happens. It's been 6 months now since you started. You haven't really touched game development or programming before this, so you're happy with what you've got done. Well, I'm glad to hear that. Yeah, I mean, making a game has a lot. There's a lot of work to it, so um, it's good that you've tried to start with something simple so you won't get overwhelmed. I think a lot of people tend to go a little bit too big for their first game. Okay, so this must be where they do it. Okay. Oh, I see. Okay, so that's interesting. I wasn't sure you could do all this stuff. So yeah, they just set the source and destination blend. Okay. Well, so now we know how to do it. I wonder. I mean, it is kind of cool to have all these options in the material so you can switch between them. That way you don't have to set it on the actual, or you don't have to make like multiple different shaders just with these values replaced. So I think that'd be definitely useful to know. So let's see if we can get this working. Oh, right. So first we'll need, I guess, a surface type variable. Okay, and this is basically just for like the editor state. Okay, and then what we'll do, yeah, so we'll draw the base below this. We don't have to do a super fancy inspector, but we'll want to basically do an enumeration. Okay, it's been a while since I've worked with the Unity editor, so let me see. All right, Unity editor enum list. I think. Okay, well, yeah, that's not really answering. It's just showing how to create an enumeration, not how to put it in the inspector. Okay, so this must be at the enumeration pop-up. Okay, so let's try that. Okay, so first we'll have public enum surface type. All right, so I guess opaque will be the default, and then we'll have transparent. Okay, so what was it called? Better GUI layout. Enum pop-up. Okay, so we're supposed to give it the enumeration that's currently selected. All right, so how do we get a current property from the material? Okay. All right, so how does it get the material? help. Okay. So we should be able to get the material from this. Okay, so material editor target as material. Okay, that makes sense. So then we want to get the current option out of here. Let's see. So we gotta kind of surround these. Oh, okay. Well, no, I guess we don't need that. You don't have to have it. That's just if you want to check to see if something has changed. Um, yeah, the Unity editor, I mean, you can do a lot with it, but it's a little confusing, and there's, again, of course, not very much documentation, but, well, this isn't too bad. Okay, so I need what I'm trying to figure out is I want to get a certain property out of this material, and then make sure I can save it to whatever the user selects. But Unity's shader editor here is very complicated, so it's kind of hard to tell what's going on. Okay, so where's it good? So yeah, it finds these properties at the beginning, I guess. Oh, I see. So you have to look through this array of properties that's passed to find the one with the name you want. Okay, so maybe I could just use these that Unity has created. Let's see. Surface property equals base shader GUI dot get, what was it? Okay, it's public. Okay, so it's this find property. I was gonna say, don't tell me it's private. All right, so I want the surface type, right? That's what I called it. Yeah. And then we need to give it this list of properties, and then I'll just set true because, yeah, it is mandatory. Hi, i3. How are you doing today? Thanks for coming by. Okay, so now we have that. That's right. I'm doing just a simple one because that's the only way that I know of that you can change a shader to be transparent or to be transparent like per material. Because I'd rather not have to write two separate shaders for that. But yeah, it's turning out to be a little bit complicated. Okay. Okay, so I guess this would be, so not just an int value? Oh, right, because, yeah, the materials don't really usually work natively with integers. So yes, the float value. It's kind of weird, but first we'll cast it to an int and then surface type, and that should work. Okay, so yeah, we'll just give it a label. Oh, I guess the label has to go first. It's kind of, that's fine. So surface type. Okay, and this returns the new enum. So type selected surface type equals. Okay, I guess I have to cast it like that. Okay, and then I can set material dot. I don't know what. No, I probably have to set it from the serialized property. Float value equals integer selected surface type. Okay, and it should automatically cast that to a float. So let's see if this works. Okay, so okay, and it does. And yeah, when we deselect it, the transparent mode stays. So that's good to see. So we've got that working. Okay, so we can look at the code. Let's see if I can find it again. Yeah, here. So I don't want to just copy and paste it. So let's see if we can figure out how this works. It'd be nice if I can have them open at the same time. Let's close that for a second. Okay, so yeah, we have alpha clipping. I'm not going to worry about that just yet. So let's make another function to update surface type. And we can do that begin and end change. Then F editor GUI. Then we can say update surface type, and we can return the material. Or not return, give it the material. Okay, so again, it has all this stuff about alpha clipping, but we don't really care about that right now. Okay, so we get the editor or the surface type from the material. Okay. And then we just gotta switch between them. Okay, so here it doesn't even have to cast to an integer, so I guess it's smart enough to do that automatically. So yeah, that will make this slightly less complicated. Okay, so what we want to do is if it's opaque, okay, so yeah, we want to set the render queue to geometry and then set the render type to opaque. The render queue is kind of just like the order that the material or that the shader runs. So transparent object should run after opaque geometry. So that way because they kind of need to have all the opaque geometry drawn first in order to see like what's behind them. Some platforms also have a separate render queue for transparent cutout objects as well, because they're kind of more they're more costly, I guess. So you want to draw the rest of the geometry first, so that way you can like do a depth test and maybe not have to draw so many of the cutout materials. At least that's my understanding of it. But anyway, so in fact, I could even just have a transparent cutout surface type instead of having a separate click button. If you set the render queue to geometry, would it still run on iOS devices? Oh, that's a good question. And yeah, the render queue name is actually, I think, badly named now that you bring that up, because it doesn't actually have anything to do with a geometry shader. That's just what they call solid, or the render queue for solid objects. Yeah, so I guess this should be opaque, but I don't know. It's called geometry. But yes, it will run on iOS devices, so that's good to know. Okay, so anyway, let's do, so for opaque, we'll set material render queue to render queue. Okay, oh, is this not some built-in thing? Oh, it is, okay. I just haven't included that. Trying to understand quaternions is hurting your brain. Yeah, well, the trick is, yeah, don't look at how they work inside. Just like kind of treat them as a black box and think of them as, you know, rotations basically. Yeah, because the math behind them is very complicated, and I won't pretend to like completely understand it either. Probably, yeah, I bet doing a whole tutorial on like 3D rotations would not be a bad idea. Okay. Okay, so we just gotta include that namespace. Okay, and then they override the tag. Yeah, that's probably a good idea. Usually I've always just used the opaque tag for cutout materials as well, but I guess we can be a little bit more descriptive. Why not? Okay, and then for transparent cutout, we'll set the render queue to alpha test. Pipe to transparent cutout. Okay. And then the last one, blending, we'll set the render queue to transparent, and the override tag to transparent. Okay. All right, so what else? Okay, Okay, so this is like if you have a Q offset. I don't think I'll worry about that right now. It's a little advanced. It can be useful sometimes, but... Okay, so now we have a source blend and a destination blend, which is a blend mode. So I guess we do need to support all this stuff. So in our shader, where is it? Basically, we just need to add a bunch more properties here. Z right, Z test, and then I'll also use okay, well actually that's not, I was gonna make one for culling, but we don't have to deal with that, I guess, right now. Okay, so how you handle this, you can see in the lit shader, they use these, basically you can put the property name in brackets and the shader compiler will like evaluate that for you, which is kind of nice for these specific commands that you can't really write in HLSL. And this mode basically lets you do alpha blending or additive blending or whatever you'd want. Which, yeah, we don't, yeah, I guess I should add all these blend modes, but I don't have to worry about that just yet. And then Z write is basically should the shader write to the Z buffer or the depth buffer, which is just another name for it. And you don't want transparent objects to write to the Z buffer, so that's why you turn that off. Okay. So source blend and destination blend for opaque and transparent cutout will be 1 and 0, because the source object is like the color, or the source blend is the color of the like the background, and the destination blend is the color of the, oh wait, the source blend is the color of whatever you're rendering at that point, and the destination blend is for like what you multiply with what's already on that pixel on the screen. So for opaque objects, obviously we want to overwrite whatever's already on the screen, so you set destination blend to 0. Okay, so we can handle that here. I'm going to kind of just use multiple switch statements just to kind of keep things sort of clean. Okay, so material, set, integer, source, blend. Okay, so I guess we have to use this enumeration instead of just using a an actual number. And then also opaque objects should write to the Z buffer. And here we just use a number. Okay, and then we can duplicate this for transparent blended objects. And so for here, we want to be able to set these with another option. But I think for now, I'm just going to do the standard, like alpha tested, which is source alpha and then 1 minus source alpha. Okay, we'll have to see about what all these keywords do, but okay. And then yeah, set Z right to off. Okay, so it's also kind of interesting that they disable the shadow caster for opaque or transparent objects, which I guess actually, yeah, that's correct because we got the shadow. Well, I mean, I guess you could put transparent blended objects in the shadow caster, but I think it would look kind of weird because it doesn't have like an alpha to shadows, so oh, you can't have like semi-transparent shadows. So we can do basically we'll just, if surface does not equal transparent blend, then we'll enable the shadow caster pass. Okay. So we've kind of got a simple setup here. Let's see if it works correctly. Okay, yeah, I just had to set it once to make sure it updated all those values. Let me look at the frame debugger and we can make sure that this material is still writing to the depth buffer while it's in opaque mode. I need to turn on, you got this screen space ambient occlusion. Okay, so, oh, okay, there it is. Oh yeah, so yeah, we haven't enabled batching yet, so that's why this is it doesn't batch with the previous. I guess it wouldn't anyway because it's a different shader, but and then if I turn on just depth mode, okay, so we can see it's writing to the depth buffer. Good to know. Okay, so now if we look back, and even if I set it to transparent cutout, it doesn't cut out. Well, one, because our texture doesn't have any alpha, but I haven't actually enabled that yet. But also, here it does turn off the shadow. But again, we don't have any alpha. Now if I... Okay, so yeah, now we can start getting alpha if I turn down the alpha on the tint. So at least transparent blending works so far. Yeah, then if I turn it back opaque, then it goes back to how it was. All right, so that's good to see. Let's... So I need to do these blending modes. I guess let's work on that, and then we can do cutout next. So, okay, so I want to... Okay, so the pre-multiply is a little bit special because it has this specific keyword that it turns on. I'll have to see. I think what this does is it multiplies the alpha with the color. I'll have to see specifically what it does. As well as this alpha modulate. Okay. Okay, so we already are using this blend mode in the here, so I'm gonna call this blend type. All right, so now I need to add another hidden option here. Okay, and then we'll basically do another editor GUI thing. Okay, so this will be, I don't know, blend property. Oh. Okay. I guess I can simplify this by just putting that there. Then I don't even have to cast back to the enumeration. Although, I guess I kind of still do because it's a system enum. Oh, really? You just do that? Okay. Guess I have to cast to the actual enumeration first, and then can I cast the integer? Okay. Yeah, enumerations are kind of annoying in C# like that. I wish that they would like automatically cast between the enumeration and an integer. It seems like it would be, it's always been useful or something that I would find useful. But I kind of understand why they don't, because it can maybe bring up some unintended like bugs if you try to assign an enumeration to an integer by accident. But I don't know, it's always annoying to have casts all over the place. Okay, so I think I did that. All right, so now this should check to see if either of these have changed, and if they have, then it will run this. But I want to make sure, so let's just have a little log here. So material changed. Okay, yeah, so the material change did fire when I did that. Okay. Also, like before, we could hide this property unless the surface type is transparent blend. But we're not really doing anything else fancy with hiding things that aren't needed, so I think I'll just leave it for now. Especially since, like I said, the patrons didn't really seem to care about material inspector. See, only one person has voted for it, so... all right, so... now what we need to do is just implement all these. First, I guess let's find out what this keyword does in the lit shader. I'm gonna drag this out for a second. Okay. All right, so it's not actually in the forward pass, so now we're gonna have to go and find where this actually appears in the code. Okay. Let's just put everything in one window for now. I guess I'll check lighting first. Okay. Oh, it's right here. Okay, so if pre-multiplied alpha is on, then it multiplies it with the diffuse, and then does this thing, something with reflectivity. Okay, so that's basically what it does, but it's handled actually in the lighting system itself. So I guess I don't have to do anything in my code. I'm gonna look in here real quick. Okay, so yeah, this gets the alpha out of the alpha channel, or I was expecting this to be a 4 because, like, I guess this is the sample from the texture. It's always fun looking through the URP library to try to find out where these functions are called. Okay, yeah, so it just calls alpha. Okay, so this is the sample alpha, and then, okay, and then that's like a tent, and then the cutoff. Okay, so yeah, the name there maybe leaves a little bit to be desired, but so this is the alpha from the texture. This is like a tent variable, and then this is a cutoff threshold. Okay, so this. Okay. Okay, so what this means is that like if the alpha channel of the color texture actually contains smoothness, then you don't want to multiply. Um, then you don't want to use it in the alpha calculation. So yeah, we're not gonna have to worry about that because in our case, smoothness will always be on the metallic and specular texture. Okay, so it seems like I'm safe just to multiply this. Maybe need to do a little bit more research about it, but well, let's see. I guess we can just search the entire Unity solution and see if it appears anywhere else besides these shader GUI. Okay, I need to add it to the material, which makes sense. Ooh, excuse me. Oh, what was that? Oh. Okay, so for this shader, they actually included the entire code inside the dot shader file. Okay, well, we're not gonna worry about that. Okay, so yeah, that only seems to only appear that one place. All right, so that's good to know. So basically we want this to be on. It's on the multiply and the pre-multiply. Okay, so I don't know what this alpha modulate does, so let's look at that. And yeah, it's never like disabled, so that's kind of weird. Okay, something with particles. Okay, so it only has to do with particles. Let's see. I wanna repeat lit blend mode. Oh, that's not what I need. Okay. Blending mode uses Dropdown. So this uses the materials alpha to change how transparent an object is. So this is just normal. Applies a similar effect as alpha but preserves reflections and highlights, even when your surface is transparent. This means that only the reflective light is visible. Transparent glass. Okay. Adds an extra layer to the material on top of another surface. This is good for holograms. Yeah, so that's fine. Multiplies the color of the material with the color behind the surface. This creates a darker effect. All right. Okay, well, I'm not going to worry about this because it only seems to affect particles, and we're not going to use particles. So we'll just do this pre-multiply on, and it's only on during pre-multiply, and that's it. Okay, so that's kind of easy. Okay, so what we'll do here is another switch statement. Yeah, and I know we could maybe clean this up, but blend type equal, I guess blend equals material get float. Okay, and why is it not like that? Oh, there it goes. Okay, so in alpha, this is just this mode. 1, 2, 3. Okay, so in pre-multiply, let's see, I don't want to get this wrong. Yeah, so the source blend is 1 because, yeah, you just multiply the source alpha into the color, but then the destination is 1 minus the source alpha, so. Okay, and then additive, they're both 1. Oh, wait, yeah, the source alpha and then 1, okay. Because you just add the semi-transparent object on top of it. And then multiply is destination color, and then so you overwrite the destination. It seems like, but oh, actually, yeah, it's kind of so yeah, you overwrite what's in here, but you use the destination color as like a multiplier for the rendered color that we get from our fragment function. So that's kind of interesting. Oh, I'm pasting in the wrong spot. Okay, so yeah, then zwrite is 0, and then we can okay, so unfortunately can't do exactly what I wanted because I wanted to just have like one call to either enable or disable a keyword, but we're gonna have to do like an if statement. I guess it's not that big of a deal. So if blend equals pre-multiply, then we'll enable the keyword. Okay, actually we need to do this below because, yeah, so if surface equals transparent blend and blend equals pre-multiply, then we'll enable that keyword. Going for a stretch? Okay, Gabi, have a good one. Yeah, I've been trying to do yoga more often, speaking about stretches, but I admit I've been a little bad on keeping up with it, so maybe schedule some time to do that after the stream. Okay, so what is the keyword? Alpha pre-multiply. And then otherwise we'll disable it. Okay. Cool. So now one other thing we have to do in our lit shader, so the code is a little. Where's my, I guess my HLSL file got closed, but we don't need it right now anyway. But, Okay, so I want to put this alpha pre-multiply pragma. Looks like, yeah, it should only have to go on the lit pass because, yeah, nothing else really cares about alpha blending. Okay, so let's do material keywords. Okay, so used and lighting dot plus all. I'm gonna do that so I don't forget that that's where I found it. And then set in the editor. Or I guess set in my custom lit editor. All right, so let's test all that out. So alpha. So first I got set to transparent blend. Okay, yeah, now this alpha should change it. Let's look at the normal one through here. Okay, and then pre-multiply. Okay, so it did change it. It's supposed to look like glass, and I think it does. Now if I change the alpha, that's interesting because even if I set, oh, okay, I guess that's reflections. So let's see. And so what this does is it multiplies the diffuse by the alpha and then adds reflective. So yeah, so it adds to it if it's reflective. That's because the reflections are supposed to stay opaque. Just like a pane of glass, so. Okay, so yeah, I think that's working correctly. I mean, there's no code in the let shader for this, so everything's just handled with those two lines in the lighting function. Okay, and then additive just adds the color to the what's behind it. We can change it red or whatever. Then multiplies the color, so everything will always be darker. Especially since this is gray. If I set this to white, okay. Okay, I was trying to figure out, even though this is all white and everything, why it was not like completely see-through when I had it on multiply mode. It's because like still like the shadow and stuff from the effect is multiplied with the final color. It's shaping up to look very cool. I think Scully. Yeah, it's nice. I hadn't ever really played around with the material editor, so it's nice to be able to like change all these transparency modes on the fly. Because usually you had to edit the shader file to do this kind of thing. So it's really nice. Okay, so I think we're done with transparent cutouts. I guess I should just check the other way around to make sure that it still looks similar. Okay, so we'll change this to transparent. Put okay, so alpha. Yeah, so that's simple. And then change it pre-multiply. Okay. I think it's like that because oh, emission turned off. So let's just change all this to white, like other one, and then oh, yeah. Okay, there we go. Yeah, I had to turn off the specular workflow to get it to look how I was expecting. Okay, and then additive. Okay, I think we're good. And change it back to opaque, and the shadow comes back. All right, so now the next thing I should need to check out is alpha cutouts, I think. So I have this cutout material, and but obviously it doesn't cut out anything right now. Even if I change it to transparent cutout mode, it's because we're not handling that yet. Now this, it's not super difficult, but let's go ahead and deal with the editor side first. So we need to do another little keyword like this. So surface type is a transparent cutout. Then we'll enable I guess I should check to make sure something else doesn't use this alpha test, like this specific name. It's gonna take a while because it's gonna show up in every shader. Okay, yeah, so it's in the surface input, which is fine because we're not using that. Hi, ZoRandom. It's been a while. How are you doing? Okay, I don't know why this got highlighted like that, but okay, so that's good to know. It seems like it only appears in this code, in this section right here, which is like what I would expect. So I can name it whatever I want. I'm just going to name it that because it makes more sense than alpha test, or it's what I'm used to calling it anyway. Okay, so we need to add another shader feature for this. And also set in custom lit editor. And okay, I closed my HLSL file, so open that back up. Oh, you're doing good. That's good to hear. We're working on some shaders today, kind of trying to, well, I'm working on a tutorial about writing shaders in URP, or code shaders in URP, so I'm kind of just working on an example shader. All right, so here what we'll do, so when you have cutout mode, you need to test, okay, so it's actually, right now I only pass the UV down through when I'm in the forward lit pass, because that's the only code or pass that actually reads from a texture. But when you have alpha clipping, you need to actually always read from the color texture in every pass. So we're gonna have to shuffle some stuff around here. Let's see. So if alpha clip, is that what I called it? Oh, I called it alpha cutout. So if this is defined, or we're in the forward lit pass, then we'll sample a texture. But I guess I'm kind of getting ahead of myself. We should pass the UV to the interpolator structure. Okay, so to do that, so I don't have to write out that like compound define statement, let's define a new keyword up here. So alpha cutout or forward lit pass. Then we'll define a new keyword here, which will just be like UV interpolator required. Okay. Oh, I actually don't even. Okay, so I haven't done anything with like changing these attributes depending on the pass. So a lot of this stuff, especially in the interpolator, you can make your shader a lot more efficient if you exclude fields and passes that don't need them. That's because basically every value in here has to be interpolated between every vertex. So you want to try to be a little careful about that. You're going to try to make a parallax layered volumetric weather system shader for your pixel art game. That sounds really fun. I've really wanted to do like procedural skyboxes more because I enjoyed that tutorial I made. It's been a while now, but you think you can do it. Clouds, mist, snow, rain, daylight, and stars. Might have a few questions for me at some point. Oh, that's, yeah, no problems though, random. Like I said, that I'm kind of interested in that kind of thing too, so. All right, so I guess we can go ahead and clean this up. So, we're gonna need the normal. I guess let's start here. So we need this. If requires UV interpolator. And then we'll also need the normal if we're in the forward lit pass or the depth normal pass. So gosh, can I type? Okay, so now we need a normal interpolator. Okay, so if requires normal. I think I'm using different keywords, aren't I? Because I think I said requires UV interpolator here, but then up here it's UV interpolator required. So we'll just go with this one. With an S. Okay, and then this stuff we only need in the, that should be flipped. Okay, sorry if you guys can hear that. And this should also be if defined. So if we're in the forward lit pass, we need all this other data. Okay. So yeah, the only thing that's needed for every pass is the clip space position. So similarly, we always need position. And so we only need UV if we need a UV interpolator. We only need normal and tangent if we need a normal interpolator. I don't really know. It's not as important to pull things out of the attribute structure, I don't think. Because well, actually I do it in the default lit shaders, but we can maybe clean up a little bit here. I'm trying to think, because now that I think about it, it might not be a good idea because, well, okay, let's check and see. What does URP do? So in the forward pass, they have basically every attribute. Now what about the Shadowcaster? Okay, let's see the Shadowcaster. Oh, okay. Okay, so yeah, they take out stuff they don't need. So all right, well, we can try and be good here. So we need the normal. So if defined forward lit pass or Shadowcaster pass or depth normals pass. Okay, and then we only need the tangent in the forward lit pass. Same with the light map. And so we need a UV basically if we ever need the UV interpolator, which we've already dealt with. Okay. So let's see. That's probably going to throw some errors. Oh, right. I always forget the if def. Okay, so the problem here is that sometimes we don't include the normal OS, so it doesn't know what to do at that point. So let's see. Okay, to make things more complicated, in the forward lit pass, we also have a tangent, which we kind of want to access. So if defined forward lit pass, then else if defined Shadowcaster pass or defined what was it? Depth normals. Okay, and then in this case we won't pass the tangent because we don't even pull that data from the mesh. Okay, and there's a version of this function without the tangent vector, but it just doesn't also convert it as well into world space. Okay, so that's fine. And then if requires UV interpolator, then we'll pass that. And then, oh yeah, if def. Almost forgot it again. So an if def requires normal interpolator. Then we'll pass this. And then if it's the forward lit pass, then we'll do everything else. Okay, so that should be, okay, we still got an error. And the normal. Okay, so it's saying that there's nothing called normal in the output, but that shouldn't be true because the forward lit pass should always have the normal because it requires the normal interpolator, doesn't it? Oh, I put a underscore there. Okay, there we go. Okay, so now we've kind of cleaned up that. It makes things more complicated, but I don't know, it's more efficient. Another strategy is to like separate every pass into its own file. You can do that, but for me that tends to make a lot of code duplication, so I don't like it quite as much. It's kind of just I don't know, preference, I guess. Anyway. Okay, so here. basically if there's a UV, then we need to sample the texture. So float 4, I guess we can pass this up. Okay. So now we need the alpha threshold. Basically, yeah, we've done all this just for the alpha cutout. All right, so we'll add something here. So alpha cutout threshold. And so if the alpha is lower than this value, then basically we're gonna not display that pixel. Start it at 1/2. And then you've got to add the property variable there so that your HLSL file can grab it. And then to implement it is actually really easy. So no, I don't do that. So if alpha test, or wait, no, that's not what I'm calling it. Alpha clip. Or I think, yeah, there's like 3 terms for the same thing. So alpha test, alpha cutout, and alpha clip. And I always forget what I want to use. Now I don't have that on my clipboard. Okay, so if defined. So you just have to call this clip function, and what it does is if the value is below or equal to 0, then it throws out this pixel. So we can just do color sample.a times tint.a minus alpha cutout threshold. I don't know why I did that. Okay. All right. So now, yeah, it's a little confusing, but for lit pass is like implicitly in here. So this would have already been calculated by the time we get to this code. All right, so let's see. Oh, actually, it is on alpha cutout. Okay, I just had to do it again to make sure it had updated. Undeclared tint. Okay, so what did I call it then? Oh, color tint. When do I actually... Okay, add it here. Okay. Well, it looks funny, but yeah, it is being cut out. Okay. Yeah, and you can't see the back because it's cold, but that's funny. I guess when you do an alpha cutout, the shader still, I don't know if you can all see that, but it's like deleting or overriding the grid lines from Unity editor. That's kind of a funny effect. But anyway, so the alpha cutout's working. Let's check the frame debugger just to make sure that it is cutting out even on other passes. For instance, I'm trying to see, is it affecting the shadow caster? It doesn't look like it. Oh, and I think that's because in my shader, I needed to add this alpha cutout pragma to the other passes. So let's go ahead and do that. Okay, I still don't have a meta pass. I just realized. Okay. I don't think I'm gonna worry about this if we're not. Like I said, my patrons don't seem so interested in recreating the URP lit pass, so I'll leave this for a later tutorial. But we do need a meta pass. Yeah, same with the detail maps. I think I'll just scratch it. thought there was a way to strike through. I think I'm thinking of a previous. I didn't want to just delete it. Okay, we'll do that. Okay, so I just did that. Well, yeah, I don't know how much more we'll add. Okay, so still don't think the alpha cutout's being applied to the shadow. Depth only, shadow caster. Maybe I need to update the material so that it does. Okay, so it's working in the. It's working on the forward lit pass, obviously. What? Okay, so look at the frame debugger. The depth pre-pass. No. Okay, and you can definitely see the cutout, so it should not show the whole thing. What about depth normals? Okay, so depth normals looks kind of weird. What's that about? Okay, so it's fine and opaque, and then transparent blend. It doesn't even draw. Oh well, that was a different thing, but yeah, because these don't write to the depth texture, so it's not going to show up. That's what you'd expect. But it's something wrong here. Okay, well, let's figure out the shadow caster first. Okay, so the shadow caster, I did add alpha cutout. Oh, I think I know why. It's because I've set this shader feature local fragment, which means this keyword only exists on the fragment stage, but we actually need it on the vertex stage because that also controls what fields are passed through to the interpolation. So I think if I just remove this little bit, it should work. Okay, yeah, and now we have a cutout shadow. Okay, yeah, and a cutout depth normal. Let's test or check out the normal depth texture just to. Okay, yeah, so it's working good too. Okay, so now we have alpha cutouts done. What else do I want to do? I guess I want to do this render face. So here, like for example, when you look at this sphere with a cutout, you can't see the inside of it. It just goes invisible. So if you wanted to have a like invisible on both sides, then you could set this render face to both. Yeah, double-sided rendering is actually a pretty interesting topic that I kind of dived a bit into in my foliage tutorial. I don't think I'll worry about like implementing double-sided normals and like shadows. Although I suppose we could, but I guess I just kind of want to show how to set a cull mode. Okay, now interestingly, I don't really have to use the inspector for this because it just needs a simple enumeration. I forget exactly the syntax for it though. So Unity, cull shader material property. Maybe this is it too. Okay, yeah, here's what I was looking for. So this, you can use this in, I guess, what's this called? What are these called? Not property. Or is it a property? But it's different than the, I guess, this modifier. And you can pass it any Unity or C# enumerator and it should show up here. And then to enable it, we just would say cull, just like any other of these special little properties here. And you want to add it to, I think, every pass, except for the meta pass, but we don't even have that yet. So in the meta pass, you always have culling off. Okay, so interestingly, it has cull off by default, or yeah, cull mode is off. So you just set it to, you want to cull the back. So, and then if you cull the front, then you get an inside out mesh, although the normals are still pointing to the outside of the circle. Like it doesn't flip the normals by default. You have to do that yourself. So I don't think I'll do anything else with the cull mode, but I don't know, in the tutorial, it will at least show how you can set that in a shader. Okay. So I guess I kind of want this to be on back by default. So can I set this to 2? I guess I'll have to create a new material to test the default value. Okay, yeah, so if I set it to 2, it's back by default, which is probably what most people would use. Okay, so what else? I guess I have to do the meta pass. What else is on the lit shader that we might want to do? Okay, so I guess we can turn off receive shadows. Let's see. Although, I don't know, that one's not, I mean, we're going to talk about custom lighting anyway, so. Oh, I need to do instancing. That's something I should handle. Okay, yeah, let's not worry about turning off shadows. I don't think that's super. Well, I mean, it does have its uses, but since a lot of my patrons wanted to talk about specifically custom lighting, that's going to kind of come up in there. Okay. I'm just kind of looking. All right. Okay. All right, so let's do a meta pass real quick. And in meta passes, I usually put it in a separate file because it's usually a lot different than every other pass. So it doesn't have any code in common, in other words. So my meta pass. And yeah, oh, and I have to change the file type to HLSL manually. Okay, so you always need to do a kind of like gateway define here just to make sure that you don't have any compile errors if I can type the thing. So my meta pass included, and then you just define it on the next line. So this basically just means if this keyword is already defined, then don't compile the code inside. Okay, and then in the shader, we just need to add another pass block. Okay, and the meta pass is basically for like emission to show up in baked lighting. That's almost all that it's used for, just for baked lighting. And like I said, culling is always off. This Z-Write, that should be in the other passes, shouldn't it? Let me look and see. Yeah, I forgot some of these attributes. So yeah, in the Shadowcaster, you want to set the color mask to 0. So let's set that up. Did I get the right one? This is kind of confused there. Okay, and then here for the, oh, I'm not doing, the gbuffer pass is for the deferred renderer, but I'm not gonna handle that in this tutorial. Okay, and then the meta path just has cull off. Okay. All right. So the meta pass. Okay, so it has a little bit about like the specular information because that could affect. And then also, yeah, we could turn on and off emission, but again, it doesn't seem like patrons were super interested in that kind of stuff, so we won't worry about it. Do I need instancing? Yeah, there's no instancing for the meta shader, which makes sense. Yeah, so we will have cutout and then the specular setup. Is that what I called it though? Yeah. Does it need the pre-multiply maybe? No. I don't even think that transparent objects can be included in light mapping. Maybe they can. Okay, so just to make this obvious, it's a different function than the other ones. I'm gonna call it meta vertex and meta fragment, and then we'll call or include the new file. So my meta paths. Okay. Oh, I already had it open. Let's go ahead and clean up some of this stuff. So Unity has its own meta paths, and this actually changed a whole lot in 2021.2. So we're gonna have to fix that ourselves, but basically you have, why would I need tangent space in the meta pass? Doesn't even use it anywhere, I don't think. Okay, that's interesting. But anyway, so basically it just sets up the surface data like we did in the normal pass. So I guess that bit is maybe duplicated. So maybe, would it be worth it just to put the meta pass in here too? I think I've run into the first problem where you genuinely think it's a Unity bug rather than your own incompetence. Well, yeah, that happens a lot. So, I mean, Unity, don't get me wrong, I love it, but there are a lot of little bugs that you can run into. I mean, it's a big program, so. But what are you having trouble with? Okay, so yeah, basically we need to duplicate this code, which there's some stuff in it that it might be better not to have to duplicate. So I'm trying to think, should I just include the meta pass in this file? It might be better if we had like a common file, but that starts to get more complicated. So oh, you posted in dev help? Oh, okay. Well, I'll check after the stream then. Well, I guess let's try it and see. Usually I put the metapath different in a different file, but usually I don't try to copy this PBR information. So, let me see here. So for the meta pass, we would need position and then UVs. So we need this UV and that one. Then the interpolators. I don't know. Maybe. I'm trying to think. So when I put all passes in one file, it's usually because there's something really complicated in the vertex function. But maybe in this case, it'd be better to put everything in its own file because the vertex function doesn't really do anything. Let's see what would look better. I guess I can show both methods. Because I mean, I can kind of follow what's happening right now, but I think it's going to start getting really complicated with the vertex, with the meta pass, because it needs like a strange combination of values. Okay, so let's make, okay, so we have mylit passes already. So I'll just call this mylit pass, or wait, so it's mylit forward lit pass is what it should be called. Okay. So we'll just copy this. Okay. Right, so in this case, we can kind of get rid of a lot of this stuff because we only need the UV interpolator. Well, we always need the UV interpolator and we always need the normals. So that's nice. Before I do this, I should have implemented what's it called? Instancing first. That's okay. Let's see here. Okay, so one important thing actually, and this is another reason that it's sometimes nice to work with one big file, is because you have to make sure that this code is this is exactly the same for all passes, because if you don't, it messes up instancing. Okay, so maybe this would probably be a good thing to show in the tutorial anyway. We'll make like a complete shader that's all in one file, and then I can show what it's like if it's separate out per pass and people can just decide what style they like better. I think one file is good for simple shaders, but otherwise it can get a bit much. Luckily this shader is pretty simple, so let's see. Trying to remember the macros for instancing. Okay, I don't have it. There it is. So yeah, you have to include this information in the interpolators. And you actually, I don't know, you probably don't need this. Close that for now. In every, because for instance, the lit pass doesn't have that stuff. What about the Shadowcaster? It has the instance ID. So yeah, I think you only need the stereo bit, which is for VR, and the forward lit pass maybe. But let's look. Okay, no, stereo is in the depth only, as well as the normal. So, okay, well that makes sense why it's not in the Shadowcaster, because you don't actually see it through your eyes. It's like through the light only. Okay, but that does make it more complicated. All right, so let's see. Okay, so the instance ID you always need for every pass, except for the meta, I guess, because there's no instancing in the meta pass. Yeah. Okay, so if not defined, well, I don't really want to do a negative thing, so let's see. If defined forward lit pass or defined shadow caster pass or defined how do you think about it? And the lit meta pass. Okay, it still uses, well, it uses the meta input, which is different. I was gonna say, like, does it even have the C buffer thing around its variables, which is what you have to do for instancing to work. Okay, it still does have the C buffer, but it's different, which makes sense. Okay, I think this kind of has convinced me. Yeah, this is gonna have to be different than the other passes, so there's really no reason to have the meta pass as part of my lit passes. So I think if you're ever making a shader that's like complicated enough to need a meta pass, then maybe you should just either separate this code into some common file or put everything in its own file. This is something you kind of have to think about, because like if we put everything in one file, then for instance, this stuff would have to be, like this logic would need to be duplicated. But I mean, let's probably you just put that in a common file then. So anyway, I know I'm just kind of talking a lot. So we don't need this stereo if not defined shadow caster pass. Then we don't need it. If we're in the shadow caster, we don't need the stereo. So let's just add instancing to this, and then I'll clean up the files and we'll do the meta pass. Okay, here. Okay, so these macros, it's kind of just fancy around creating like an array for these values, and that just enables instancing so that every material in the instance doesn't have to have the same properties. All right, so that's that, and then we need to pass the instance ID. All right, so here. Okay, and again, we don't need the stereo in the Shadowcaster. Okay, so yeah, this, you have to call the setup instance ID in any function that uses any of these values up here, because that basically makes them available in the shader to use. For instance, in the fragment function, we need to call it again. And then we also have this set up for the stereo vision. Which again is if not defined Shadowcaster pass. Okay, so did not find. Oh, okay, so it's complaining that my meta fragment's not set up, but yeah, that's true. Comment that out for now because we kind of got sidetracked. Okay, so now I want to create two of these objects and just make sure that instancing works. So we just put two and make sure that they're visible on the screen. I think I'll hide the default Unity one just to make things a little simpler. Okay, so now when you look at draw opaque objects, okay, so this is the URP lit shader, so that's the ground, and then the next batch is our two spheres. Like, I think they fixed this in later versions, but in 2020.3, the frame debugger doesn't really work very well, because even when I click here, it shouldn't show that the spheres have been drawn, but yeah, it's a little buggy. And then also in here, it's also been batched. You can see, yeah, it has two draw calls because it's one for each sphere, but it's still, they've all been put in one batch, so it doesn't have to like upload the mesh data to the GPU multiple times, so that does speed things up. But yeah, I don't think this, you don't even have to use that in URP, I don't think. Okay. All right. So now that's set up. So again, we just need the meta pass. Usually what I do is I basically just use Unity's meta pass, but we still have to get like I said, this code down here. So one thing you can do, it probably is a good idea to just make a common file that, and we'll just pass up this information, and then also we can include all of these values, because like every non-meta pass needs to basically have the same like properties in order for instancing to work. And it's kind of nice because like to have separate files, because then this is really simple. There just is some code duplication normally, but if we're careful, maybe we can handle it well. So I guess, like I said, I'll leave this like combined pass file, and it's like maybe one. I'll showcase this option or this style, and then this other multiple file style, and people can see what they like the best. But I think it's time probably to make a folder with all of these so that they don't take up the entire shader folder. Okay, so well, I mean, there's an argument that the actual shader file could maybe stay outside, but I don't know. Okay, this should be renamed to my lit metapass. Yeah, it's kind of, I mean, another thing is that it's kind of nice to have the shader all like in one file, because otherwise it gets kind of unwieldy to deal with. But that was the nice thing about surface shaders and what's it called, in the built-in pipeline, because you could basically just needed one file and it would kind of generate everything for you and take care of a lot of this busy work. But someday it's supposedly on the roadmap for URP, and I'm definitely looking forward to that. Anyway, okay, so we have the lit forward pass. I guess I'll just copy this over again because we added the instancing. Okay, my lit forward lit pass included. Okay, I guess first what we should do is we should make like a common file. So my lit common, And then we'll have another one that's like just common for all the non-meta passes, basically. Okay, and what would we add in here? We would add, so this mostly be helper functions. I think really the only thing we would add in this file is this code, because this basically has the thing that's included with like the non-lit passes and then the meta pass. Well, I mean, the compiler is smart enough to include this in things that aren't needed. So let's maybe rename this to mylit like functions or helpers. And then I'll do like the Unity style where we'll have an input file which includes all the like the property variables. Okay, so we don't have to copy. I'll write that all out again. I guess I should rename this file. Okay, so the basically that would include all this. Okay, so this is stuff that's included in basically everything except for the meta pass. And then, so to grab that, we would just hashtag include mylit non-meta input. So that means we can get rid of all that. And yeah, we don't need this stuff either in the forward lit pass. Okay, so for the forward lit pass, we pretty much need everything. We need position, normal, tangent, light map, and UV. So I can move that around just to make it more organized how I like it. Okay, so then we have UV, normal. I'm gonna do the same thing here. Okay, and so things like this, we should be able to include in the common file. Oh yeah, so the view direction and shadow chord. Actually, I think this will only be needed in lighting. View direction might only be needed in lighting, so maybe this can just stay here. Okay, this is like for the shadow caster, so I'll get rid of it for now. Okay. So yeah, we need all this stuff. Oops. So, I mean, in a way, everything is a lot cleaner. You just got to be careful that if you do like any actual logic, you don't want to, you want to be able to put it in the helper file so that you can copy or share it. Like, pretty much the main thing is this part. And then when we test the alpha clipping. So let's do, so we have this, So void test alpha clip float for sample. Oh, okay. Okay, and then the rest of the stuff is actually in the input, so okay, and yeah, so this will only do something if the alpha clip is defined, or I always see this alpha cutout. Otherwise, basically, it's an empty function, and the compiler will delete it. So yeah, we don't have to worry about it being included. Oh yeah, for some reason this file's open twice there. So what I want to do is call this, excuse me, the color sample. Oh yeah, then this should have my lit helpers. Oh, sorry, I don't know what got stuck in my throat. Okay, don't need that stuff. But basically, most of this can stay the same. So now I need to define this here. Okay, so like I said, I need to somehow put this in a helper function so that the meta pass can grab it, or have this logic without us having to include it multiple times. So create surface input, and yeah, it's gonna need a bunch of stuff, but I guess mostly it just needs the color sample. It just needs these samples, so maybe it's not too bad. Flip 4, and for some reason it needs the tangent space normal. I don't really know why, but we'll give it to it. And then it needs the occlusion sample. And the emission. Okay, and I guess we won't do clear coat. It's really not even in the lit shader. I think it's only in the complex lit shader, but okay. So then I can just here. Did I copy that? Okay. So color sample, metallicity, smoothness sample, occlusion sample, emission sample, and then for some reason the tangent space normal. Okay. Cool. All right, so now we can do the Shadowcaster pass, which is going to be quite simple. I think I'll just copy this one. Okay, so Shadow Caster. Oh, there's no G in Shadow. Okay, so this will stay the same. For attributes, it only needs the position and the normal. Oh, and the UV. It doesn't need light map stuff. For interpolators, it only needs UV for alpha clipping. Besides that, that's all. Oh yeah, and no stereo and shadows. So it doesn't need this stuff. It does not need Oops. Does need that second line, but doesn't need stereo. Okay, there's no tangent vector. Okay, so what it needs is that Shadowcaster special stuff. Let's see. That I had here. Although I guess now it doesn't need the if not defined. And this is to take shadow biases into account, basically. So we give it the position in world space and then the normal in world space. Okay. Yeah, it doesn't need to pass any of this stuff. Okay, so here, no stereo again, and basically it just tests for alpha, and if there's no problem there, it just returns. Okay. And the depth the depth pass is even simpler. So my lit depth only pass. Okay, so it needs no normal. Does not need that. Okay, so it actually can go back to the old method of getting the clip space. Okay, yeah, it still needs the UVs for alpha clipping. Although I guess it only needs the UV if alpha clipping is enabled, now that I think about it. So, let's see. If defined alpha cutout. I need to make sure that's the actual. Okay, that is. Okay. Same here. Okay, so yeah, if we're not an alpha cutout, then we can just basically return 0 right away. I don't even think we have to deal with instancing because we don't use any properties. Okay. All right, Gabi. Yeah, I'm gonna about to sign off as well, I think. But I wanted to finish setting up some of these passes. I'm sorry to hear that's causing you trouble. But yeah, I'll check out your post and see if I can help on later today. But yeah, thanks for coming by, Gawi, and I'll see you later. All right, let's see. It's kind of annoying that I have to rewrite all that stuff that I just did, but that's okay. All right, and yeah, again, we only need the UV in certain instances. Okay, but this time we're gonna have to have stereo. So I need to add this back into the interpolator, and I need to pass this. Yeah, and I'm not sure, the stereo might need the instancing properties or the instanced properties, so I'm just gonna call this set up even, and just in case. I mean, it's not gonna be a big issue if it's not like it'll cause it to eat up like tons of frames if for some reason it doesn't need it, but okay. And finally, we'll have the depth normals class, which is slightly more complicated. Okay, so depth normals pass. Okay, so the depth normals pass needs the normal vector, obviously. Oh, yeah, the depth only pass doesn't need that. It would have been stripped out anyway, but okay. So yeah, and then we also need normal here. I don't really know if the order of the text chords here matters, but since it always has to have this first one, it'll just be in 0, just in case. Okay, so we'll do that, and then let's check out this so I can grab this correct code here to decode or encode the normal into a color that goes into the depth normal texture. Okay, so I think this is done. Oh yeah, this should be world space position. And I don't store it yet, so. Okay, so now I've done everything except for the meta pass, but I guess that's gonna wait until next stream. So let's go ahead and update our shader to use these individual files instead of the giant one. So we don't need these defines anymore. So it'll be my lit forward lit pass. I'll just copy that. So I don't have to copy or retype quite as much stuff. Shadowcaster. Depth only. Depth normals. Okay, so we got a problem. Undeclared emission sample. I probably just spelled it wrong. Oh yeah, I had put 2 M's. Create surface input void function. Oh. Implicitly convert from float 3 to float 4. Oh right. So normal is just a float 3. Okay. Implicit truncation of vector type. Alright, so let's see where that might have happened. Okay, yeah, this should be a float 4. Though we don't really use the alpha. Okay, so that's good. Let's check to make sure everything else is still working. I see shadows. Oops, this is the wrong window. Okay, depth prepass showing up, still batched. Okay, depth normal still showing up too. Okay, and it is on alpha cutout. I guess I should turn off alpha cutout just to make sure that. Okay, yeah, an alpha cutout still works. Okay. Yeah, so now we just pretty much have the meta pass left to go, and then I think well, okay, I guess we need to implement another version of the shader that has custom lighting and see if there's a good way I can like integrate that in. Yeah, because that was pretty high on the list. So what else? Okay, well, this mostly a lot of this stuff I can't really do on stream because it's kind of just like writing how I want to explain it. But I probably will make like showcases for it eventually, I guess. Maybe little diagrams. I don't know. Okay, and for debugging, okay, so basically I've been doing it where I show the frame debugger. You can like output normals and stuff. Okay, but yeah, so the main thing we need to do is the meta pass and then custom lighting. Oh, I need to add in 2021.2 features because there might be. I need to make sure the shader is compatible with it because there might be some. Well, I know for a fact that the meta pass has changed a lot, but there might be some other stuff. So yeah, we'll probably look into that. But I think for now I've got to sign off. Thanks everybody for coming by, and I hope you have a great weekend. I'll be live again on Monday about the same time, which is like yeah, 2:30 US Eastern time. So I had to think about time zone conversions. But and then we'll continue with this. Maybe well, I bet we'll probably continue with this. But yeah, I hope you all have a great weekend. I'll put some links in chat if you enjoyed this stream and you would like to connect with me, or check out my YouTube channel where I have a bunch of Unity tutorials. But yeah, I'll see you later and have a great day. Bye-bye.